3. And we will review them every time till the end of the semester. So a plus b squared.
A squared
Yes.
plus
Yes?
2ab
Awesome.
plus b squared.
Do you want to know that calculus students don't know this? Okay? This is extremely important. Okay, what about the second one?
A squared minus 2ab
Very good.
plus b squared.
Good. In other words, you are really saying first term squared plus 2 times the first times the second plus the second term squared, or with a minus, correct? Okay, now this one. So, I don't have kids, but I do remember that my first steps, everybody probably remembers the first step was 1 foot and then the other, right?
Yeah.
Well, this is the 1 foot and then the other in algebra. That's why we need to remember them. And not just remember them with A and B, because as you know, it can be anything, right? Okay, third one.
A squared minus b squared.
Yes, it's a difference of squares. Why is this so important? It's because now we start chapter 6 and we are going to learn how to go backwards from the right hand side back to the left hand side. So that's why every time between now and the end of the semester, I am going to present this first. Okay. Now, I would like to go through this handout. So this is a handout that I gave you a while back. It has 4 pages, back to back, except the last one. This is the entire chapter 6, everything in chapter 6.
You didn't happen to hear that out last weekend, did you?
No, it was a long time ago.
Oh, then I must have it.
I have another.
Thank you.
So this is the entire chapter 6. We are going to finish it, hopefully today, everything, all these pages today. And starting from next Saturday, we will do each and every problem in the book from this chapter. Okay? Everyone, you have this? Yes? You have it? Okay. Good. So let's start. So this is chapter 6. See, I still want to write 17. I am not in 18 yet. Found it? It's the one that says chapter 6 at the top.
Sure. Oh, yeah.
Okay. Where is it long? Yes. Okay. So chapter 6. Chapter 6 deals with factoring. If you ask me, can I do without factoring? I would say in certain situations you can, but many, many, many times you cannot. So this is like a skill that it's necessary in math. I would say it's necessary in math. Like we learn to drive because many of us, we don't have a driver, right, to drive us around. So we have to get from one place to another. So driving is a skill. Yes, other people will say it's a privilege. We have to be very careful, la la la. I understand that, but it's a skill that we had to learn to survive or to do what we wanted to do. Well, factoring is a skill that it's an algebraic skill that will help you in any math that you're taking. In any adventure in math or advancement in math without factoring, you will have a hard time. Okay? So we're mainly looking at 3 different types of polynomials. Of course, it's factoring polynomials. The accurate title is factoring polynomials. And we will be looking, so this is the reason why I don't want to open the book from the very beginning, is because the book is organizing this topic in a totally different way that I organize it. The reason I organize it in 3 different categories, category 1, category 2, and category 3. Category 1 is binomial. Category 2 is trinomial. And category 3 should be anything else. But by anything else, we say polynomial. How many terms does a binomial have? 2 terms. How many does a trinomial have? And here I'm going to say 4 plus terms. In the back of my mind, I'm still thinking, the fact that, Chris, you missed last Saturday, that could have been, unless you watched the video, because we reviewed a lot last Saturday.
Yeah, I didn't.
Okay. Okay, so the book does not organize it like this, by categories. The book is all over the place. That's why I don't want to open the book just yet, till we acquire the skill, or at least we make the first few steps. We know how to put it in gear and how to put the brakes on, right? So once we understand what's happening here, the book, chapter 6, will be a smooth ride, okay? The other reason why I organize the factoring polynomials in these specific 3 categories is because when I say binomial, I want you to think in terms of the strategy for the binomial. And I'll give you the strategy. It's also written in there, but it's difficult to read. Allow me to explain it, and then we can read it together. When I say, what is this polynomial, and we agree that it's a trinomial, I want you to forget about binomials and have in mind the strategy for a trinomial. When we say, okay, what is this? And you say it's a polynomial, then you will have to put aside binomial and trinomial. Do not think of those, but think in terms of the strategy for polynomials. Okay? So I don't want you to mix them up because they are completely different. So the strategy for binomials has certain special products. The strategy for trinomials has other special products. And here we don't have special products. The main idea will be pretty similar, however. Okay. So let's start with binomials. When I'm given a polynomial to factor, the first question I ask myself is, what is it? Since we haven't discussed anything yet, in this situation, the answer will be binomial. Question number 2. Is it in descending order? I don't care what the book says or what other books say. Polynomials have to be presented in descending order at all times. Number 3. In this case, we're talking about a binomial. It has 2 terms. I'm going to ask myself, do these 2 terms have a common factor? If they have a common factor, I have to pull it out. Number 4. Remember in the past, in chapter 5, I asked you many times, what is the leading coefficient? What is the leading term? Identify the leading term, identify the leading coefficient all the time, correct? Okay. So once the polynomial is in descending order, I know what the leading term and the leading coefficients are, right? I know what they are. Okay. If the leading coefficient is negative, even if there is no common factor, I will pull out -1. So negative leading coefficient. So if there is a common factor and a negative leading coefficient, you can consider these to be done in one step if you wanted to, which is fine. It's recommended. Step number 5.
Or you said if both of those are true? Or if
Yes,
one-
of course, of course. If there is a common factor, let's say 2x,
Right.
and the leading coefficient is negative, I will pull out negative 2x.
Got it.
Number 5, special products. There are 4 special products. I don't have enough room here, so I'm going to the next page. This is the end of the strategy for binomials, but first we have to discuss these 4 special products. So a squared minus b squared, a squared plus b squared, a cubed minus b cubed, a cubed plus b cubed. So let's go to the first one. What do you think the name of the first one is? It's a difference of 2
Terms squared.
perfect squares. Okay, perfect. I'm going to write that down for you, with you. So difference of perfect squares. Okay. So a squared minus b squared, how does it factor? How do I factor a squared minus b squared? Can anyone tell us how to factor a squared minus b squared?
You use the third.
So I'm here. How do I factor a squared minus b squared?
Do you mean when given a question or?
Okay. Maybe something I should have said and I didn't say it. When we have 2 terms, which is a binomial, and we want to factor this, what do we really mean by that? What are we trying to do? So I have x squared minus 4, and I want to factor it. What does that mean? It means that I'm changing a sum or a difference of 2 terms into a, when I say factor, what operation do I mean? Product of, how are these called now? That's what I didn't write. So let's do that first. Okay. I'm coming back to this page. This is not clear. Obviously, I did not emphasize. Okay. So if I have 2 terms, let's say x squared minus 4, these are 2 terms, and I want to factor this into these 2 quantities. How are these quantities called? This quantity and this quantity. So this must be a product. If I want to factor, this has to be a product. I'm changing a sum or a difference into a product. But these cannot be called terms. They are called terms when they are added or subtracted. Now, this quantity, one quantity, and this is the second quantity, are called, if they are multiplied, they must be called, that's it. So when I'm asked to factor, it means that I'm given a polynomial, 2 terms, 3 terms, 4 terms, they're all added. That's why they're called terms. And I want all this thing to go away and be changed into a product of maybe 2 or maybe 3, maybe 4, I don't know, but factors. So this is the process of factoring. Changing a sum of terms into a product of factors. So I'm going to write this down. Factoring means replacing. And if you're asking me why we do this, there are plenty of applications. Chapter 7 is an application of this. Solving equations is an application of this. Tons of applications. This one doesn't have a lot of applications. This one has a lot. So I want to change this into this, and we'll solve it in a minute. So factoring means replacing a sum or difference of terms by a what?
Factor? No, a product.
Very good. Of
Two factors.
two or more factors. That's good. Two or more factors. Because I don't know, depending on the polynomial I'm given, I may have more than two factors. So this is the process of factoring. Okay, so now we are back. Any questions so far? Okay, so coming back here. We're trying to factor a squared minus b squared. We established the name of this expression, which is basically we're looking at it and we see first term squared minus second term squared. We don't really see a and b, right? A and b is just generic, but we really mean first term squared minus the second term squared. And we want to change this into a product of what?
Factors.
Product of factors. How do I change it into a product of factors?
Is it A point
So I'm coming back here.
A minus B?
Yes.
A
I need this the operation that follows. You said a minus b, I agree, and then I need an operation.
coin.
Times,
A plus B.
that's it. That's why we discussed this.
But the only thing is like, how did you get there though? Because I feel like you're saying that because you know what the inverse of the formula is. Like, how do you actually?
Right.
You know what I mean? Like,
Right,
how do you actually
because we proved this to be this a month ago.
Right.
And then I said, we have to remember this. So I'm not going to FOIL this. You can if you want to. Two terms will go away because they cancel out. And now knowing this, I have to know the reverse. That's what I said in chapter 5. Stop foiling this because we're going to have a hard time in chapter 6, going backwards. Now, as long as I have it in my mind that a plus b times a minus b is a squared minus b squared, you can give me any a squared minus b squared, I will come up with the other two.
Okay. So the point is to memorize.
Once we proved it, it should get it embedded in. We should get it embedded in our system.
The only thing I don't understand is like for the bottom one, like how do you know it's minus? Because you have a plus and a minus, so it's always hard for me to remember.
A squared minus ab plus ab minus b squared.
It's like positive.
That's what I'm saying. Once we did it in chapter 5, it has to be embedded now.
No, it's not.
So FOIL it. FOIL it for the last time. But it has to become embedded because you're putting yourself up for failure.
I mean, I'm trying to learn it. I don't know any good tricks to memorize this. Is what I'm telling you.
First term plus second term times first term minus the second term is the first term squared minus the second term squared. We proved it.
Okay.
Prove it one more time on paper. I'm telling you how. A squared minus ab plus ab minus b squared. Those two terms are canceling out. Use the FOIL. Write it down.
No, I don't. I mean, I don't want to use the FOIL. You told me not to use the FOIL.
But to prove it one more time, to refresh your memory, you have to FOIL it now. Hopefully that moving forward you will remember it. So do it one more time right now on the side of the paper somewhere. And you'll see what you get. But moving forward, I'm hoping you will remember this. Is this okay? Did you cancel out AB with negative AB? And did you get A squared minus B squared? Yes?
Second. Oh, okay. Yes, yes.
Because if we don't understand it in chapter 5, or cement our understanding in chapter 5, now we're going to go back and say, how do I get that?
Right.
Okay, good. The next one. So we know the special product, the difference of squares, factors into A plus B, A minus B. You can write it as A minus B times A plus B. It's the same thing. Okay, A squared plus B squared. Name first. What do you think that?
Sum of perfect squares?
Of course, of course.
Okay, I was gonna say two.
Sum of perfect squares, of course. A squared plus B squared equals not factorable. To be exact, I will put in parentheses using integers. Or even real numbers in this case. Okay, please give me the name of the third one.
Difference of perfect cubes.
Awesome. And since we are here, so I don't have to go back there. What do you think is the name of the last one?
Sum. Perfect cubes.
Perfect. Okay, so let's talk about the difference of perfect cubes. Before we do that, I would like us to, we have not discussed these two ever before. This is totally new. So I would like us to multiply this binomial by this trinomial. And you can say, how did you come up with that? I just want us to multiply these two. And you'll see in a minute. How do I multiply a binomial by a trinomial? This comes from chapter 5. Sorry. Dictate, please.
A plus B. A minus. Ooh.
I have to distribute A to 3 terms.
Are we using FOIL or are we not using FOIL?
You have to.
Oh, okay. FOIL.
That's why I said, how do we multiply a binomial by a trinomial?
That would be A times A squared.
Yes, which is good.
And then it would be A times minus AB.
So I have to write the symbol first. First, I multiply the plus by the minus. I don't multiply with minus in there, right?
Gotcha.
So first the sign.
A times AB, which would be A squared B.
Very good.
And then A.
I need sign.
Plus,
Yes,
A times B squared.
very good. So I'm done with A. A got distributed to all 3 terms. So then now,
B squared
I can't. I have to write a symbol.
plus
Yes,
B squared.
yes. And I'm going to write it A squared B because it's the same thing. Perfect.
Minus
Correct.
B squared A
Very good. But I'm going to write it AB squared, so I always keep everything in. And then,
plus B cubed.
awesome. Do we all agree with this? That's how we learned how to multiply or, right, distribute, in other words, terms from a binomial to a trinomial. I have two terms. I have to distribute both to these. You could have done it reverse, but I think it's easier the first way. A squared to these two, negative AB to these two, and B squared to these two. But I think this is better. Now look at what we got and tell me what to do next.
See if it's any descending order.
Just look at the terms first.
Okay. Is
Since we have two variables in here, we have to decide how to present it, right? But just look at it first. Any suggestions?
I'll take anything cubed and put it to the left first. So I would do like A cubed plus B cubed.
Okay, so we put these two.
Yeah, and then I think we're going to do whatever's cubed that matches. So we have AB squared minus AB squared. So those would negate each other, right? You can just cross those out. And then negative A squared B plus A squared B would negate each other too. So that means you're left with AB.
How do we call this?
sum of
Sum of, oh, you already wrote it.
Um,
You already told me what it is.
Sum
Perfect
of
cubes.
perfect cubes.
That's it. So then one more time, can anyone tell us how to change the sum of cubes into a product of two factors? Can anyone dictate?
A
Plus
plus
B.
B.
In a parenthesis?
Yes.
Good.
Rounded. And then another parenthesis. And then it's A squared minus AB plus B squared. It's the problem you have.
So this is the way we factor the sum of cubes. Very interesting. Into what is this? A what? How do we call this?
By
Yes. How do we call this?
Turn over.
So we haven't seen this before. We had a difference of squares which factored into two binomials, right? A product of two binomials. But this one is the sum of two cubes. It's a binomial, but look at it. It factors into a binomial times a trinomial. I want to emphasize the sequence of signs. If we are factoring the sum, the binomial must have what sign?
Addition sign.
And the trinomial in the middle must have,
Subtraction.
exactly. We don't ever talk about the last one. The last one is always positive. So remember now that when we factor the sum of cubes, the binomial follows the same sign, has the same sign with what I'm factoring, but the trinomial has to have in the middle the opposite sign.
Wait, so are you saying the first thing that we went over, the difference of perfect squares, you said that one's factorable, but that also has an addition and a minus sign in it too.
Yes.
That's
The
not a
difference-
coincidence, I'm assuming?
No, it's not. So the difference of squares is a product of two binomials. One with a sum and one with a minus in any order you want. It doesn't matter. When it comes to the sum of cubes, if I factor the sum of cubes, the binomial has to have the same sign in the middle. But the trinomial has to have the opposite in the middle because otherwise those four terms will not cancel out.
Okay.
So knowing this pattern now, can you please tell me what will happen if I wanted to factor now the difference of cubes? Can you come up with an idea? Dictate it and I will put it in. What do you think will happen here?
Is it A minus B
Of course.
parentheses
Yes.
A squared minus
If all these are minus, my terms will not go away. So if it's plus, plus, and minus, obviously minus, minus, and
Plus
plus.
B squared.
No, I can't.
A,
It has to be a trinomial.
Oh, yeah, that's right. AB
And then
plus B squared.
that's it. So this is how we factor the difference of cubes. Again into a binomial and a trinomial. And the sequence of signs is similar, but this time it's minus, minus, and plus. So if I factor the sum, the binomial follows suit if you want, and minus in the middle of the trinomial. If we factor the difference, then the binomial follows suit, and the trinomial has positive in the middle. This is the end of the strategy for binomials. Now we are ready to practice. We're going to practice all sorts. Okay, one more time, so let's go through the strategy. I'm given a binomial to factor. The first thing that comes to my mind after I look at it, I'm asking myself, is it in descending order? If it isn't, I will rearrange it. The next step is, does it have, those two terms have a common factor? If they do, I pull out in front the common factor. If the leading coefficient happens to be negative, I will pull out a common factor with a negative leading coefficient, with a -1. Now, if it only has a negative leading coefficient but not a common factor, I will only factor out -1. Then I move on to the next and the last step, in which I try to match the binomial I have with one of the listed 4 special products. If it's a difference of squares, I'll factor it as a product of 2 binomials. If it's a sum of squares, I'll say, sorry, not factorable. If it's a sum of cubes, then I'll say a binomial times a trinomial. If it's a difference of cubes, then I'll say a binomial times a trinomial accordingly. Any questions before we look at problems?
Can I see the previous notes? I think I missed writing something. The previous notes before this. Oh no, after that. No, I mean the formulas for the different of perfect cubes and stuff. This one. I think I missed something. I want to write it down.
Here,
Yes. Okay. Which one is not factorable?
the sum of squares.
Alright.
Okay, before we look at examples, at the end of that handout, there is this. This summarizes what we just discussed about binomials. So let's take a look. It's at the end of the handout, the last page of the handout. And also I put it in as a loose leaf. Yeah. Okay, so first I have to make sure the polynomial is in descending order. Secondly, I have to find the greatest common factor and put it out. Thirdly, if there is a negative leading coefficient, I have to factor it out. And then look at those 4 special products. They're right here. When it comes to a binomial, you see the difference of squares, you see the sum of squares, you see the difference of cubes, and you see the sum of cubes. Okay? And that's the end of the strategy. And now we're ready to work on problems. And I would like to work on this problem that I put up here when we were talking about what is the difference between terms and factors. So this is x squared minus 4. I have to go through my strategy step by step. Do not skip any step, because you get yourself into more work, basically. You make it harder on yourself. So once you get used to factoring, this will happen very fast in your mind. Okay, what is it? Can anyone tell us what is this? It's a binomial. Is it in descending order?
Yes.
Is there a common factor present in both terms? Correct. Is there a negative leading coefficient?
No.
No. So I'm down to quickly to the special product. So now I'm asking myself, either from here or from here, which of these four are possible? Obviously, only two of them I should even consider because it's a difference, right? I will not consider this one, and I will not consider this one because the binomial I have is a difference in the middle. So I will consider these two. Now, all I have to identify is whether this term in our binomial is a perfect square or is a perfect cube. If you say a perfect square, then you will have to think of the difference of squares. If you say a perfect cube, then you will have to say a difference of cubes. So please tell me what it is. Yes. Once you said perfect squares, you will have to come up with two what? Two, yes, but they are what? What type?
Factors.
Yes, but what type?
Binomials.
Exactly. Because if you say the difference of cubes, you're not going to come up with two binomials. You're going to come up with a binomial and a trinomial. So that's why that's the difference. That's very important. You said difference of squares, prepare two binomials. If you say difference of cubes, you will have to prepare a binomial and a trinomial. So please prepare two binomials whose product will be x squared minus 4. In any order. How do I know? It's because I'm asking myself what do I square to get x squared, so it has to be x. What do I square to get 4? It must be 2. And I know the pattern. Is this okay? Yes? Is that a yes or no? Okay, next problem. On page 2, by the way, you can put those in as a summary if you want to. On page 2 at the top, you have these again. Okay, that's where I'm looking and picking problems. Okay, so let's say x to the 4th minus 81. I'm going through my strategy. What type of polynomial is it? Binomial. Of course, we haven't discussed anything else yet. Is it in descending order? Is there a common factor present in both terms? Is there a negative leading coefficient? No. So now I'm thinking of 4 special products at the end of the strategy. Since there is a difference between those terms, these have no place. So I'm thinking of these two. If I identify that this is a perfect square, then I'll go with this. If I identify that this is a perfect cube, then I'll go with the difference of perfect cubes. Yes. Once you say that, then you will come up with 2 binomials. It is the difference of squares.
S squared
Yes?
plus 9.
Very good.
S squared minus 9.
Very good. Every time we are asked to factor, by the way, we are asked to completely factor. What does completely factor mean? It means that the factors I got, if they themselves are further factorable, I have to continue. I cannot stop. So I'm here now. X squared plus 9. Bless you. X squared plus 9. Which of these special products will I look at or consider? Number 1, number 2, number 3, number 4. 1, 2, 3, 4.
It's number 2.
It's number 2. What do we know about number 2?
Can't factor.
Perfect. Now the other one. I have to check whether this is factorable.
Yes.
Which one?
It's the first one.
Exactly. So I have to continue. I will copy x squared plus 9. I cannot drop it. It has to stay. But when you say x squared minus 9 is the first one, then you will give me 2 binomials. Please give me 2 binomials. And I shouldn't be writing it here because I will squeeze it in.
plus 3x minus 3.
Now this binomial, x to the fourth minus 81, is completely factored. And as you see, it has three